Hey everyone, welcome back to our YouTube channel. In today's video, we'll be seeing the solution for the fourth question of Division 1, that is Domain of Gobar Singh. So let's understand the problem statement at first. We are basically given with a network or a grid consisting of X rows and Y columns within it. Now, we could indicate any particular square or a cell within the grid by two coordinates, that is A and B, wherein which A indicates the row index and B indicates the column index. Now we are supposed to construct a bus system over this particular grid which is given to us. Now it could be done within two different phases. The first one being we have to choose two different squares within the grid and we have to construct or build a bus stop over these two squares. Now the cost for building a particular bus stop at a square AB is given by CAB rupees. Similarly, we have to also construct or build roads connecting these two bus stops. Now the overall cost is given by this particular expression over here. So consider that my first bus stop is constructed at a particular square or a cell AB and the second one at a square A dash B dash. So the distance between these two of them is indicated by this particular expression. So if we take a closer look at this expression, it is nothing but the Manhattan distance between the cells AB and A dash B dash, which we generally give by the expression that is the absolute difference between the x coordinates adding it to the absolute difference between the y coordinates. It nothing but indicates the Manhattan distance between these two cells which are there. Now we are multiplying it with m. M nothing but indicates, let's say I'm constructing a road from the current cell to the next adjacent cell from the current cell. So the cost for doing so is indicated by m. To have a closer look, let's say this particular grid. So my first bus stop is over here and my second bus stop is over here. Now there could be multiple possible paths or multiple ways of constructing roads between these two bus stops. Consider that I have constructed the road like this. Now m will be the cost required in order to construct the road starting from this cell till this cell. So in order to construct this particular road, I'll be requiring m cost. Similarly, I have to construct the road starting from over here till over here. So the total distance between these two coordinates will be multiplied by m, because m nothing but indicates the cost for constructing the road between two adjacent squares itself. This is nothing but is indicated by the expression which is given within the question. Now we basically have to determine the minimum possible cost for constructing the entire bus system, which is specified by these two rules. Now let's take a look at the input format. So we'll be having three different integers as the first line of input, which indicates x, y, and m. And what these three integers specifies is indicated within the question itself. Then we'll be having the matrix as the input, wherein which each coordinate or each particular element within the matrix is given by is nothing but specifying the cost for building up the bus stop at that particular square. And as usual, we have to output the minimum possible cost for constructing the entire bus system. So let's see how we could solve this particular problem statement. So consider that I have my first bus stop over here and I'll be having the second bus stop over here. Now, the total cost in order to construct roads, including the bus stops, or the total cost required for constructing the entire bus system, we can say, is given by the expression that is m into your distance between these two coordinates, as we have seen within the question itself. This is nothing but the expression which is given over there, plus again Cij as indicated within the question. This Cij or Cab nothing but indicates the cost for constructing the bus stop at that particular cell. So in order to construct the first bus stop at, let's say, this particular cell, will be having the cost for the same, and similarly we'll be having Cij for the second bus stop which is there, and this m into d nothing but indicates this particular expression which is given over here, the cost for constructing the road between them. This is my total cost and I have to minimize this particular total cost which is required. So I can have multiple ways of constructing roads over here. Likewise, then we can go like this as well. So we have to determine the minimum possible cost between these paths. Now let's say I have a particular bus stop over here and I have to go over here. As of now, we'll consider two possibilities. We can go from above like this, or we can go from sidewise like this. So we are considering two directions, that is the direction from above and the direction from left hand side. So consider that I have a particular matrix which is Mn, and such that each cell ij within this Mn matrix indicates the minimum cost to reach cell ij. Now there could be different possibilities that we'll be seeing. So let's simplify this expression more. Consider that you haven't constructed any particular bus stop yet, and this is your first bus stop that is supposed to be constructed. And let's say I have constructed the bus stop over here itself. So this one will be my first bus stop. In that case, we could have the minimum cost as Cij, because Cij indicates the cost for constructing the bus stop at that particular location, and it's my first bus stop, right? So we can have it as simply Cij. Else what we can do is, as we have seen, let's say it's your second bus stop. So in terms of second bus stop, you'll be having certain movement, you'll be constructing the road, right? So let's say this is your second bus stop, which is over here. So either you can construct the road in this particular direction or from the left hand side. Now let's say we are coming from above and we are constructing the road like this. So in that case, we can write down the expression as like this: I minus 1 and j, wherein which I minus 1 nothing but indicates that we are coming from the above. So we'll be adding m to it as well. Now as I said, m nothing but indicates that say I'm constructing a road between two adjacent squares which are next to each other. So we'll be requiring m rupees for that. And in order to construct the entire road, we'll be multiplying m with the distance between these two coordinates. Now as I'm coming just from the cell which is above it, that is I minus 1 row, hence we are adding only 1 m to it. Similarly, we can come from the left hand side as well. So we can have it as I and j minus 1. Again, I'll have to add m to it. Now to simplify things, let's say this is your I, this is your I. So in that case, this will be your I minus 1, right? So I'm coming from over here to over here. Likewise, and let's say this is your j, and this is basically your j minus 1, right? So I'm coming from over here till over here in the left direction, as you can see over here, and hence I'm adding m to it. Now this is what my simplified expression would look like. Now we go on exploring these possibilities and we go on constructing our answer that we require, that is the minimum possible cost for constructing these bus stops. Similarly, if you'll see, we haven't considered these two cases, that is, let's say my bus stop is over here and this is my second bus stop, and let's say my first bus stop is over here. So from this particular bus stop, I can come in the right direction or I can come from downward direction as well. In these cases, let's see how we could compute it. So within the formula, we have to replace j minus 1 with j plus 1, and just that we have to run the loop in reverse direction. Or else you can go by the second approach as well. You can simply swap the elements by dividing the matrix in half. So you can simply swap these elements with the elements in the other half of the matrix. However, the convenient approach is will be starting from this particular location and will be going in reverse direction till this particular column. Obviously the row will remain as it is, so we'll be simply changing the j index, and this is how we'll go about it. Now let's implement this logic in code and try to solve the question. So at first we have imported the necessary libraries that are required, and then we are initializing INF to a certain maximum value. INF nothing but signifies infinity over here. So in order to obtain that, we have this particular expression which is written. Similarly, we are also initializing n to a certain maximum value. Now we'll be having two different matrix. The first one, in order to store the cost, which is indicated by this C matrix, and the second one, which is your MN matrix, which we have used within this approach, which indicates the minimum cost to reach to a certain cell that is indicated by I and J in terms of indexes. Now we have X, Y, and M, which we are taking as the input, and then we are taking the elements within the matrix, which is C, which indicates the cost for constructing a bus stop at a particular index indicated by the square or the coordinates, that is I and J. Now we are using this memset function in order to initialize the elements within Mn to the infinite value, and this will be the third parameter, which indicates the number of bytes which are supposed to be initialized with this INF within this Mn, which is your matrix. Now we'll be traversing this particular grid which is specified to us. So obviously I will be used for iterating over the rows which are there. So we'll be starting from 1 till up to x. We are using less than equals to over here. Then we'll be starting j from first column till the yth column which is over there. Now Mn of ij will be initialized with the minimum value out of this particular expression that we have written over here, and I have already specified what this actually means. So consider that this is your first bus stop that you are building. In that case, you will simply be considering the cost for building the bus stop. You won't be considering the cost for building up the road, right? Because it's your first bus stop. Now in case it's not your first bus stop, it means that it's your second bus stop that you are constructing. So either you have come in this particular direction, which is the downward direction, or from the leftward direction. In that case, we'll be having this particular expression. So Mn of I minus 1 and j, which indicates you are coming from the upward direction, plus m. Similarly, if you are coming from the leftward direction, then this will be your expression. And likewise, we are considering the minimum value out of it to be initialized to Mn of ij. Now, in order to compute our answer, we are initializing answer as a certain maximum value once again, because we have to take a minimum value out of this value and the minimum answer that we are supposed to construct. So again, we'll be iterating over the grid, or again we'll be traversing the grid which is given to us. I will be used for the iteration within the rows, and G will be used for iterating through the columns which are there. So for the answer, will be taking the minimum out of the current answer value, or this particular expression that we are obtaining over here. Now, what exactly this indicates is, consider that you are coming from the upward direction, or you might be coming from the leftward direction, out of which one is giving you the minimum cost that will be taken into consideration. Let's say you are getting the minimum cost when you are coming from the upward direction, then Mn of I minus 1 plus and j will be considered. Then we'll be adding m to it, obviously, as we have seen within these expression, whether you might be coming from left side, whether you might be coming from upward side. Obviously, if you are traversing between adjacent cells, m will be added as a cost for constructing the roads between these two adjacent cells. Now, what is this Cij? Cij is basically the cost for constructing the bus stop at that particular cell which is there. As you are considering your answer, it means you have constructed your first bus stop at this particular location, which will be your minimum one. That is, it gives you the minimum cost while constructing the bus stop at that particular location. Now, again, you have to repeat the same process for the second bus stop, or for constructing the second bus stop basically. So we'll be iterating from 1 till up to x in terms of rows, and as I specified, you have to iterate it in the reverse direction. So j will be starting from y till up to 1. Now the reason being, we haven't considered the right and the downward direction in the upper cases. So in order to consider them, we'll be iterating in the reverse direction, and ultimately your cases gets reversed. That is, when you iterate from this direction to this particular direction, ultimately this becomes your left hand side, and likewise. So minimum out of Cij and mn of I minus 1 comma j plus m. Now that we have reversed the j direction, so obviously we'll be adding 1 to it rather than subtracting 1 out of it. So likewise your formula will be modified, and same thing you'll repeat. Similarly for the answer as well, you'll be calculating the minimum out of the answer and the minimum out of the rightward direction or the downward direction, and then adding m to it, and then adding the cost for constructing the bus stop at that particular index. Ultimately, you'll be getting the minimum cost for the total construction of the bus stop, and you'll be simply outputting that particular cost that you are getting. And this is how you can write down the code. So after running it, you can see that the sample test cases are satisfied. Let's try to submit the code. So it's accepted over all the test cases.